Hello, dear friend. This is Himmet. Now, this is our last lecture, which is lecture 14. In this lecture, we consider Taylor and Maclaurin series. In this lecture, our main objective is to use the ideas of infinite series to study function. Our main problem is like this. A given a function f, can we write the function f as a power series of the following form? Now, the answer of this question is the following theorem. Suppose that f is a function which can be differentiated over and over again at the point x equals a. Then, if we write the function f as a power series of the form, then the coefficients j sub k of the power series must satisfy the following equality, which is j sub k equals the kth derivative of f evaluated at a over k factorial for all k. This series is called Taylor series, centered at a of f. In the special case, if we take a is 0, then this series is called Maclaurin series of the function f. Now, we have a remark for you. Note that there are some functions which cannot be represented as a power series. For example, if we look at the function f of x is absolute value of x, and then we know that this function doesn't have the derivative, and so this function cannot be represented as a Taylor or Maclaurin series. Now, let's give some example for Taylor and Maclaurin series. First example is example 1. Let's find the Maclaurin series that represent the function a e to the x. Now, solution is like this. We have that the derivative of e to the x is equal to each of them, that is first derivative, second derivative, and so on. All of them equals to each other, which is e to the x. And so if we take x is 0, then we see that f of 0, f prime of 0, f double prime of 0, and so on, kth derivative of f at centered 0 is all 1 for all k greater than 0 or equal to 0. And so the coefficient of the series is 1 over k factorial. Therefore, the Maclaurin series for the function e to the x is this infinite sum. That is, the function e to the x can be written as a infinite sum for all real number. The example 2, find the Taylor series for the function ln of x centered at a equals 1. Now, solution is following in here. If we take the derivative of function f, then f prime of x is 1 over x, which is x to the minus 1. F double prime of x is minus 1 times x to the minus 2. F triple of x is minus 1 times minus 2 times x to the minus 3. And 40 derivative of f at x is minus 1 times minus 2 times minus 3 times x to the minus 4. If it goes like this, then kth derivative of f evaluated at x equals minus 1 to the k minus 1 times k minus 1 factorial x to the minus k. Now, if we take or if we put x equals a equals 1, then we have this result, and so the coefficient of the power series is minus 1 to the k minus 1 over k for all k greater than or equal to 1. Therefore, the Taylor series for ln of x centered at a equals 1 is such a infinite sum. Now, the example 3. Please again find the Maclaurin series for f of x equals cosine of x. Now, take the derivatives of the function f. The function f of x is cosine x. F dash of x is minus sine of x. F double prime of x is minus cosine. F triple of x is sine of x. The 40 derivative of f at x is cosine x. Now, if we put x is 0, then we have such an equalities, and then the coefficient of the power series is equal to this one, we know that. Then j sub 0 is 1, j sub 1 is 0, j sub 2 is minus 1 over 2 factorial, j3 is 0, and so on. Therefore, the Maclaurin series of the function cosine of x is this infinite sum. Right. Another question is another example is example 4. Now, find the Taylor series for f of x equals 1 over x centered at a equals 1. Now, if we take again the derivative of the function f, then we have such an equalities, and then the coefficient of the power series is equal to minus 1 to the k, and so Taylor series for 1 over x centered at a equals 1 is such a infinite sum. Now, example 5. Let's look at example 5. We know that this geometric series is equal to 1 over x 1 minus x for absolute value of x less than 1. At that time, we can call this series Maclaurin series. By using this geometric series, then I think we can find the Maclaurin series for some other function. For example, if we replace the x on both of sides of the above equation with minus x, then we have, if we put here minus x minus x, and then 1 over 1 plus x is equal to this infinite sum. Let's look at here. 1 over 2 minus x can be written as a Maclaurin series like this. But here we would like to get such an expression, and so here x is replaced with x over 2, and then we have such a infinite sum. Now, if we look at part C, then 1 over 1 plus 5x is equal to this infinite sum. Here we are taking 5x instead of x in this equality, and then we have such an infinite sum for this under this condition. Now, let's write the Taylor series for 1 over x 1 plus x centered at a equals 4. Now, to write the Taylor series for this function, please write the series in terms of the powers of x minus 4. If we consider this remark, and then we can write that 1 over 1 plus x is equal to this function, and then if you follow the manipulation, and then I think you will get this infinite sum for this condition. Be careful, we have to put such a condition, convergence of this power series. Thank you.